So this session will see another type of serial communication, that is SPI serial communication, and how the data is transferred. Next, Raspberry Pi SPI configuration. So first, SPI is a common communication protocol which can be used in different devices like SD card modules, RFID card reader modules, and 2.4 gigahertz wireless transmitter or receivers. All use SPI to communicate with microcontrollers. So one unique benefit of using this SPI serial communication is that data can be transferred without any interruption. That is, any number of bits can be sent or received in a continuous stream. Whereas we have seen the previous one is of bit by bit, and I2C is bit by bit and UART is clock signal. So, but this is the continuous stream of data can be sent using SPI serial communication. Next, device communicating via SPI are of master slave relationship. Master here is controlling device which is an microcontroller, and slave takes the instructions from the master. So slave can be usually, it can be a sensor, it can be any display or any memory chip. So the simplest configuration of SPI is single master, single slave system, but one master can control more than one slave. So these are the pins in the master and slave relationship. That means in order to transfer data or communicate data from one device to another device, in SPI serial communication you have 4 lines. So first line is MOSI, abbreviation of MOSI is master output slave input. So the meaning of this is this line is used for the master to send data to the slave. In the same way, second pin MISO. MISO abbreviation is master in slave out. So this line is used for the slave to send data to the master. Next, SCLK, it is the clock line. So this line is used for clock signal. In the fourth line, SS or CS. SS here stands for slave select. CS stands for chip select. So this line is used for the master to slave to select what is the data that you want to send to the slave. So here master is going to select any of the line here, either it can be slave select or chip select. Master will select to which slave I want to send the data for communication. So these are the 4 lines where you can communicate the data. So the clock signal synchronizes the output of data from the master to the sampling bits by the slave. So 1 bit of data is transferred in each clock cycle. So that's why we can measure the speed of data transfer in determining the frequency of clock pulse. Next, SPI communication is always initiated by master, since the master configures and generates the clock signal. Not only this communication, in any communication you see initiation is done by master itself. So next, any communication protocol where devices share a clock signal, we call them as slave select. The master can choose which slave I want to send the data and which one I want to talk to. So by this you can set the voltage level. You are setting the voltage level to low to which slave you want to communicate. And if you are in an ideal state, so no transmission of data is been done, then the slave select line is kept at a high voltage if you are not transmitting. If you are selecting some slave to communicate, then we will set the voltage level to low. Next, multiple CS or SC pins may be available on the master. So it depends upon the different types of master board you are taking. In some of the master boards you will have only one slave select pin, or you can have multiple slave select pins. So which allows multiple master to the slaves communication. So all these slaves are connected in parallel. So this diagram represents multiple slave. One master, it is going to communicate to multiple number of slaves. So this is done, why? Because you are having multiple slave select pins. So all these masters will be in a parallelly wired fashion. Next, SPI can be set up to operate a single master and a single slave also, and it can be set up with multiple slaves controlled by a single master. Now there are the two ways how you are communicating between the master and slave, whether you are communicating to one master to one slave or one master to multiple slaves. So there are two ways to connect. So multiple slaves to the master. So if the master has multiple slaves select pins, suppose if master has multiple slaves select pins, then the slaves can be wired in parallel. This is one thing. And if you have, that is if here means master have only one select pin, then the slaves can be displayed in daisy chain line pattern, whatever the diagram you are seeing. So if this is correct, if the master is having only one slave select pin, where all the slaves are being aligned in daisy chained fashion. If you see the previous one, here you are having multiple slave select pins for one master. So this can communicate to multiple slaves. So these are the two different ways how you can communicate the data. Next is you are having two pins MOSI and MISO. So how the data is being transferred using these two pins, in this slide we will see. So the master will send data to the slave bit by bit in serial fashion. Master will send data to the slave through MOSI line. So the slave will receive the data sent from the master at the same MOSI pin. So data sent from the master to the slave is usually sent with the most significant bit. So this is important. Whenever the data is sent from master to slave, usually will send with a most significant bit first. In the same way, the slave can also send back data to the master. So that can be done using the line or a pin MISO in a serial fashion. So the data sent from the slave back to the slave is usually sent in a least significant bit first. So here these are the two things here. If the data is sent from the master to the slave, we will send it with a most significant bit. If the slave want to send back data to the master, then least significant bit we are going to use. Next, these are the steps how SPI data transmission is been done. Same thing, but you are learning in a step by fashion. If you get a long answer, then you can choose answer from this slide. So first step is the master output the clock signal. Every time the master will initiate the communication between one device to another device. So the figure here shows master outputs the clock signal. Next, the master switches SC or CSI pin to the low voltage state, which activates the slave. Next point is the master sends data bit by bit to the slave along the MOSI pin. Here the data, here just we are initiating and here we are sending the data. Zeros and ones format bit by bit, you are going to send it through MOSI line. So the slave will read the data after receiving. Next step is if a response is needed, the slave returns data bit by bit to the master along MISO pin. So these are the two pins. If the slave is sending back data to the master, this line is activated. In the previous slide, if you see, master is sending data to the slave, so MOSI pin is activated. So this is the table which tells us what are the different types of serial communication till now we have seen, and what is the type of the communication, and what is the duplex method it supports, what is the data transfer rate. So UART was the first SPI serial communication. So that is of type asynchronous, peer to peer, full duplex it will and then 20 kbps data transfer will be done using UART. In the same way I2C, it is a synchronous type, and the relationship between the master and device is master slave relationship. It will support half duplex and the data rate is 3400 kbps. Next, SPI is also a type of synchronous and the relationship is master slave relationship. It will also support full duplex and the data transfer is greater than 1000 kbps.